Hey everyone, I decided to record a series of videos. I called them Watch Me Do Things kind of videos, and I basically wanted to do some stuff today, and I thought, oh, I'll make a video and people might appreciate it. So what is it the thing that I'm gonna do today? So as some of you may know, I've been working on a product called UboPod, and if you want to learn more, you can click on the links in the video description to learn more about UboPod. But today I want to really focus about some PCB assembly work that I have in pipeline to do for a while. So what is going on here? So I have this micro USB range extender. Basically, when I designed Ubo, I wanted people to be able to insert the MicroSD at the back of the device. So I have one of the devices here. You can see where the MicroSD is located. So so I moved basically the MicroSD card for Raspberry Pi to the back, and as you can see, I can insert the MicroSD card here in the MicroSD card reader, and there's this cable which has an FPC connector here, and this one is basically a PCB that has the shape of a MicroSD card, and then this will go and connect to the it has to actually go from under this thing, but you get the idea. So it would go from under the board into the Raspberry Pi card slot. And so there were a bunch of design issues here. First of all, this connector was a little bit finicky, so sometimes it would get loose, and or it would come out because it's a very small 8-pin 0.5 millimeter FPC connector, so it's not very reliable. So to increase the reliability of this FPC connector, I decided to get rid of it altogether. But how did I do that? So I basically redesigned this to be one piece, but this is a flex PCB, but this is rigid. So how did I overcome that part? That part was overcome with this piece of, I think it's 0.8 millimeter thickness PCB, and it's just like a bare PCB. There's no traces, nothing on it. And I used this, and this side, this thing has an 3M tape on it. So I basically taped this over this, and this part becomes rigid. And as you can see, there are no connectors here anymore. The connectors are basically the connector is removed, and it's just a one piece. But then I'm still gonna have another connector here, which is a little bit still in certain cases a point of failure. So I want to make this one also more reliable. So let's do this. Actually, let's remove this piece. This video might get a little bit long. I might speed things up a little bit and do some editing work. But let's do this thing together. So it's just like a sticky on one side. I just align it, press, done. I think I'm going a little bit. Yeah, it's better now. As you can see, I can just like put it in the SD card reader, like SD card, into the Raspberry Pi card slot, and it's fully inserted. So I can take this on the other side, take it from here and connect it to this connector. Let's do it now, just real quick. Actually go with the other order. I do this part first. It doesn't matter, I don't want to do that right now, but you get the idea. So this gets connected to this connector, but this one is a very small connector, sometimes breaks. It has if I can focus on it a little bit more. Yeah, so it has like a small lever that sometimes can get broken, so it's not a very reliable connector, and I don't like it. So what I did is that I redesigned this PCB with a larger connector. So what I did was basically I took like a 16-inch connector and redesigned this piece, and this is actually much wider than this one. So it has I basically increased the width of the connector on the FPC cable to match the connector. Now we have a bigger connector which is more reliable. It doesn't come off as easy, and this side is the same. So today I want to do a test run. I want to assemble the reader and the FPC connector, and then just test this end to end and make sure my design is working. So how do I do that? So these two are SMD components, and in order to assemble SMD components, I use stencils. So I have one stencil here. I can show you here. So stencils are basically pieces of sheet metals with the light reflection makes it really challenging to show this on the video. But as you can see, there are these like cutouts that I have to align with the pads on the PCB, and I would put paste through the cutouts onto the PCB, and then I place the components and put it in the oven to reflow. So in the next part of the video, I'm gonna start doing this. So I'm here at the laser cutter. I mounted the workpiece here, so I'm gonna laser cut that area, and also after that I'm gonna laser cut that, and just gonna do like a quick frame. Okay, looks good. I'm just gonna close the lid on the fumes, and I'm gonna start the cut. Perfect. Now I'm gonna go do the other side. Alright, great. We have the cut here. I'm gonna put the PCB on it just to double check everything. Close this, and that's the test that I do. I'm gonna rotate this, and from here I gotta make sure that all the pads are kind of not touching anything here in the bottom. So you can see all the pads are now free. So the next step is to assemble the microSD card reader. So this is not still assembled, and also the FPC header. So to do that, we're gonna put the board here, put the solder paste, assemble the components, and then we're gonna put the board into this reflow oven. I wanted to assemble more components here, but because today I'm a bit tired, I'm just gonna validate this change in this build process, and then I have a few changes that I want to validate, and I'll do that in a separate video. So let's get started. Everything looks good. Just a little bit of a notch, and I'm gonna start. So this is gonna take around 10 to 15 minutes, and then I'm gonna take it out. Just want to show you some stuff here. This is the temperature profile. So it goes up to 200 degrees, and then it goes down. So, and this is kind of time. I don't know exactly what the unit is. It's probably minutes. And it's almost at the peak now, and it's gonna come down. You can change this profile. This is the profile that has worked for me. Might be a little bit too high for the FPC connector, but I'm just gonna leave it here, and this is gonna go down now in a bit. Yeah, so it's basically a very handy tool for SMD soldering. I think I had to update the firmware on this a very long time ago, but it's been quite reliable since then, and more consistent. So it's done. It's a little bit at an angle, but I looked at the I looked at the connector under the microscope. Everything seems connected okay. You can see it's a little bit at an angle. It's not like perpendicular, or yeah. So that should be okay. I'm gonna do a functional testing next, and everything else looks pretty good here. Okay, now it's the time to perform functional testing. So we have the sideboard, the FPC cable, and a Raspberry Pi. So I already programmed a SD card for the Raspberry Pi, and it's booting up to the desktop. What I'm gonna do is I'm gonna turn off the desktop. I'm gonna go here and turn off, shut down desktop here. Then I'm gonna start connecting the PC cable to the sideboard. So just go in like that. Then you press this in, something like this. And let me get some more light here. Yep. I'm gonna connect this to the SD card here, and then connect the SD card to the reader here. So let's put this back here. I'm gonna use both my hands, turn this off, take out the SD card, put it here, and then let's connect this one here. Actually, it's gonna go like this. Sometimes this can be a little bit tight. Yeah, I think there's a little bit of I need to fix this thing. Okay, it goes in. We have everything connected. Let's turn on reply and see how it goes. As you can see, the LED light is flashing, which is good news. But I have to wait. Yes, it's booting up. The next thing I usually do is that on desktop I go to the preferences, and then here there is maybe it's in the preferences. Where is it? Pi configuration? No, it's in accessories. Sorry, it's called Raspberry Pi Diagnostics. Yeah, and then I'm gonna run the test here, which is gonna give us some test results about the SD card. So it's running SD card speed test, and it passes. Let's look at the show log, and yeah, so we are well beyond the limits in the speed, and here you can see we're at the 622 and 5, which is above 500, and 2000, which is above 1500. Everything looks good, and I can declare this change is validated. Thanks for watching this episode for me. It was my first episode. Please let me know if you have any suggestions on how to improve these videos. They're kind of free form and I need to do some editing, but I hope that you enjoyed this process.